Hey guys, this is Mrs. Gassler, and we're going to talk about lens ray diagrams. Now, I just love drawing lens ray diagrams, so this will be fun for me. You're going to want a pencil with an eraser, just in case. A ruler is going to be helpful. I'm going to start by drawing some concave. Oh, hello, I wrote mirrors on there. That should say lens. Drawing some concave lenses and some convex lenses, and then you will also want a copy of this packet, which should be printed in the classroom there, so that we have some things to work with here. So much like the one we did last time, or for mirrors. All right. In fact, they're kind of similar. So we're going to start by talking about the convex lens. And for a reminder, the convex lens is the one that comes out like this. And I'm going to draw that as good as I can, but that's terrible. It's all right. You can pretend you know what it is, right? Okay, so there's my convex lens. Now, it's helpful to remember whether this is the converging or diverging lens, and if you remember, this one is the one that does focus the lenses. This is the converging lens, where the concave lens is going to be the diverging lens. All right, so in order for this to work out, I have this line. Remember, this line is called my principal axis, okay? And I need to draw what's called the center line here of my my lens. That center line is more important than the edges of the lenses because it's at that center line where our rays will change direction. Rays turn here. Okay, so I'm not going to change it when it hits the lens. I'm going to change it when it gets to here. The reason we can do this is because it's very much known. The shape of this would obviously be better than my drawing. And we could draw the individual turning there, but it boils down to the whole focal point. And so the focal point is more important than anything else. So I'm going to draw a focal point on here, and I'm going to put it 3 centimeters away. And I'm going to draw one on the other side because it's a convex lens on both sides, which means it has 2 focal points, and they're going to be the same distance away. Now there's another spot which we'll call twice the focal length. It's kind of like the center of curvature, but it's a little bit difficult to think about because it's on the other side. But so this is F, and this is F, and this is 2F and 2F. So remember, that's the focal point there. And so I'm going to do this much the way I did the last time. I'm going to have my image, which for today we'll start with one that is 8 centimeters away. And so I'm going to draw an arrow, and I'll make my arrow 2 centimeters tall. There we go. And so that right there is my object. And I'm going to draw my lines much like I did before. My first line is going to go parallel to the principal axis. And then because this is a converging mirror, when it reaches that center line, it's going to then turn toward the focal point. And because this is a lens, it's going to go through. Okay, so here's my line. I'm going to make it as parallel as I can. It's going to go here. When I get to that center line, that's when it's going to turn toward the focal point. And there. So that's my first line. Now my second line, last time we drew to the focal point and then it turned, and you can do that here. Also, the lens ray diagram is a little bit difficult, but the easier line to draw goes, it goes through this intersection right here. It goes straight through where the center line and principal axis meet. That intersection. And it doesn't turn. Okay? So I'm going to stick that there, and then I'm going to put that there, like so, and I'm going to draw this line straight through there. Where these guys meet, that's where my new image is. That's my new top of the arrow. And so my object looks like that. So this is my image. Okay. So last time we talked about image attributes, so we'll talk more about those again. When it comes to a convex or a converging lens, it's like a converging mirror, which was the concave mirror. But they are either real or virtual. They could be either with this one. They are either upright or inverted. And they could be magnified or reduced. It could be either one. So it depends on where you put that, and we'll talk more about that here in just a second. So let's look at the concave lens. Now the concave lens is the one that looks like this. Okay, and just like we did up here, we need a center line, and so I'm going to draw this as perpendicular as I possibly can here. There's that center line. And then I'm also going to have my focal points in here, and I'm going to give them 3 centimeters. So I'm going to put the 6 in the middle. So there's my focal length, there's twice the focal length, 9 and 12. So here's F, and there's the other F, and that's 2F, and this is 2F. And I'm going to stick my image, let's put my image here at, what is that, 1, 2, 3, 4.5 centimeters away, and I'll make it 2 centimeters tall again. So there, oops, this isn't my image, this is my object. Alright, so there's my object, and I'm going to draw the exact same lines, but because this is a diverging mirror lens, then the focal point that I turn to, remember it's the same directions as up here, but I have to choose the right focal point. So I'm just going to make a note here, lines, same as above. Use other focal point. Okay. So here's my object. So my first line goes parallel to the principal axis. There you go. All right. Parallel to the principal axis, and then when I get to that center line, it's going to turn. Converging means it's going to come together over here. This is diverging though, so it's going to go off that way. So I'm going to aim it at the other focal point, and then it would go off this way. But because that's never going to meet any of the other lines, I'm going to extend this one over here, because remember, like we did in the mirror, sometimes our image ends up over here. That makes it a virtual image. This one is a real, the first one we drew was a real image. This one's going to end up being a virtual image. So my next line goes from the tip through that center point there, where the center line and the principal axis meet. And so I'm going to draw my line nice and straight right there. As you can see, those are never going to run into each other, but they do run into each other right here. So this is where my image is. Now, just like for the diverging mirror, image, attributes, these will always be virtual, because we can't put something there. This is if this were a mirror it would work, but it's not. It's a lens. These are virtual, they're always upright, and they're always reduced. Okay? So that's how it works with a, what do you call it? A diverging lens. Okay? Alright, so grab this little packet here and we'll practice here. It's got some of these here that tells you you can go back. We're going to practice identifying the object too, and we're not going to do all of these, but you can do some more of them. We just did the one where it was past F, and so we know that it is going to be between F and 2F, and it is going to be inverted, reduced, and real. This one here, when it's at 2F, same set of lines here, parallel. There's that center line, it's marked, and then I'm going to go toward the focal point. And then this next one is going to go straight through that center line as best as I can line it up. And then we'll see right here's my image, and it should be at 2F. So when it's at 2F, your object is at, if your object is at 2F, your image is at 2F. 2F. And it is inverted, it's neither, and it is real. So we would have an image there also. on the back side, if you turn the page here, we've got a few more. If it is between 2F and F, we go parallel toward the focal point. And then here we're going to go through that center line. Gee, I hope I made my line long enough. And you can see now that it is farther than 2F. So I'm going to write that it is past 2F. Still inverted. This time it's magnified and it is still real. I can still project that on a screen. This next one is going to be fun here. If I draw it just right. This one goes parallel to that center line, and then I'm going to turn it toward the focal point. And then right here. And you can see that these lines are parallel and they will never touch, and so there is no image. Okay, I'm going to get these lines out of the way here. Made those a little too long. Sometimes I go a little overboard trying to make sure I know where they meet. All right, now this next one is even more fun, and it worked like this on the mirror also when it is inside of the focal point. I'm going to go ahead and dash this one over here because I know the answer. These lines are not going to meet, so I have to push it over here like that. And right here is my image. Okay, so make a note here, never meet. They're going away from each other. But you can see over here it is behind F. It's between 2F and F on the same side of the mirror, of the lens. Same side of the lens. And it is upright. It is magnified, but it is virtual because it's not a mirror. If this were a mirror, that would totally work, but it's not a mirror. So I end up with a virtual image there. Okay, so let's look at some of the concave lenses. Now remember, these are diverging lenses, so they look a little bit different. So I'm going to go straight across to this, and instead of going towards this focal point, it's diverging, so it's going to go away from that focal point and toward this one instead. So I'm going to draw some lines here, and that's the way the light would go. And then you can see when I start here and I go through that line where they intersect, these two lines will never meet, but they do meet over here. And so there is my image. It is between F and the lens, and I'm going to note that it's on the same side as the image. It is upright, but it is reduced, and it is virtual. And then let's do this one here when it is inside. And then we're going to go toward this focal point. The light wouldn't go over here. It would go this way. And then when I go through that center point, those are never going to meet, but hey, they met right here. And so there's my image. It is, again, it is between F and the mirror, which is where most of these are. It is upright, it is reduced, and it is virtual. Upright, reduced, and virtual are what we're going to circle every time we draw one with a diverging lens or a diverging mirror. So that sums that up. That's all we've got here. If you have any questions about drawing ray diagrams, make sure you let me know. Thanks for watching.